Our next presentation is an update on Pfas, and as you probably heard in the news, this has been something that has been subject of news due to that tragic that happened, the airplane, antique airplane that went down on Bradley International Airport. But we have one of the leaders, Need Beecher. He's a special project manager. From 1998 to 2019, Ned Beecher was executive director of NEBRA, tracking research, legislation, and regulations, and providing information to members and the public. He's now special project manager and has focused much of his work in the past 2 years on PFAS, biosolids management data compilations. NEBRA advances best practices and sustainability in biosolids recycling. Ned has led projects and authored articles, papers, and books, chapters on biosolids management in the Northeast, Eastern Canada, and around North America. He received the New England Water Environmental Association Biosolids Management Award for 2015, and he has an MS in Resource Management from Antioch University and a BA in Geology from Amherst College. He has 2 adult children, and he lives in Gardens using biosolids with his wife, Chris Klein. Beecher?
Thank you. All right. Thank you all very much, and I'll try to go through this expeditiously since this is the last presentation and you all are getting ready for lunch. So NEBRA is a regional biosolids group. There are several of these kinds of biosolids groups around North America. And we were funded by our members, public wastewater agencies and biosolids management companies and others, and engineering firms and such. And a couple of our board members are here, Art Simonian and Deborah, who just spoke. And we appreciate the service of them and our and all our volunteer board members and committees. We work closely with NUIA, and we appreciate the collaboration we have with Mary Berry and others at NUIA. As was just noted, I've stepped aside to be special projects manager, and Janine Burke-Wells, who was the president of NUIA last year, has taken over as executive director of NEBRA as of this past May. So biosolids, our focus is recycling resource recovery from biosolids, and that can include everything from energy recovery, for example, at the Hartford facility, as well as recycling to soil. So when we look at organic waste that's generated across the U.S., across modern countries, or anywhere, there's several different things. There's the yard and leaf waste, there's biosolids, and there's food waste. And this doesn't actually include agricultural waste, which is another major organic waste material. And there's many things we can do with these kinds of organic waste. They all have similar attributes. They have carbon in them, which can be important for the carbon cycle, returning those to soil or managing them in some way. So what we're looking to do at NEBRA, and our members are striving for, and in collaboration with others across the country and many organizations and states and the EPA, is to maximize the beneficial uses of biosolids while minimizing potential risks. And the benefits come in the form of water, organic matter, nutrients, and energy in wastewater and in the biosolids that come from wastewater. We like to stress that biosolids improve soils. You put organic waste into soil, including biosolids, and soils are improved. They grow healthier crops. The soil management system is healthier, and it's good for farms. There's some really cool kinds of projects that go on with reclamation uses of biosolids, which I think is sort of the magical side of it, and perhaps the most stunning and helpful way to use biosolids or other organic wastes, where there's no topsoil in some places that have been mined in the past and nothing will grow. You can take this recycled material, engineer it carefully, make a topsoil layer, and with one-time application create an ecosystem where there was just deadness. Organic matter, adding compost, biosolids, agricultural manures, et cetera, to soil has many benefits, well demonstrated by research, increasing carbon in the soil, which is good for mitigating greenhouse gas emissions, increasing microbial activity, increasing water holding capacity, et cetera. So we're recycling biosolids, we're managing biosolids because they have to be managed, but also we can find a lot of benefits from this kind of resource recovery. And one of the top ones to mention at this point is greenhouse gas emissions reduction. So depending on how the biosolids are managed, even depending on how they're managed through incineration or landfill disposal or land application or anaerobic digestion, these all have impacts on net greenhouse gas emissions. So this is the field is moving forward. California especially is in the lead on looking at the climate change or the greenhouse gas footprint of biosolids and wastewater management programs. So I encourage you to look at resources that are listed here for more about biosolids. But let's get into PFAS. Contaminants of emerging concern have been around with us, for a long time. We've dealt with PCBs, dioxins and furans and trichlocarbon and triclosan, things like that, have been in biosolids, have been in wastewater, have been a concern, have been studied. A lot of understanding about how the different kinds of chemicals work and what the potential risks are when they're present in wastewater, when they're present in biosolids, and what happens with them, the fate and transport when you manage biosolids or wastewater, where are the impacts, and what happens when you incinerate versus landfill versus land apply these different materials. So PFAS is kind of a worst case, I think, at this point. It is the biggest impact I've seen in my 20-some years of working in this field. But there are concentrations of contaminants of emerging concern, CECs in biosolids, and that's been well documented over the years, various studies. On the far right here is where the perfluorinated compounds are. So they're not in very high concentrations compared to some other trace contaminants of potential concern. But all of these need to be evaluated. They have been evaluated. They are being evaluated. Research goes on. One of the things we like to stress is that when it comes to biosolids recycling, putting these materials into soil, biosolids to soils, we're talking about trace amounts of these chemicals being there. And does that, again, we're taking advantage of the percents of nutrients that are in these materials and the percents of carbon that are in these biosolids. So we're taking advantage of those benefits. But do these traces in the low parts per million for metals, or traces of parts per billion, do they have impact? And generally, for the vast majority of trace contaminants, putting them into a microbially active soil is an excellent concept. A soil has the ability to break down a lot of things. A lot of organic compounds are just food for the microorganisms. The impacts are much better known in the aquatic environment. There is not the capacity to break down chemicals as much in the aquatic environment. So doing what you're doing, getting it out of the wastewater into the solids, and then managing the solids is the best general way to go with these trace contaminants. I want to point out in the green box here that we need to remember that we're going to now, as we get into PFAS data in the next few slides, we're going to be talking parts per billion and parts per trillion. So I'm going to just pause for a second and then compare that second to what a part per trillion is. So this second right here, I'll now wait 31,700 years. So 1 second in 31,700 years is 1 part per trillion. So I have to continually remind myself, we all have to remember that we are regulating PFAS in parts per trillion, which 1 part per trillion is 1 second in almost 32,000 years. That's a tiny, tiny amount. And that's important because that's not easy to do. Okay, when we look across the US and across the world, the two kinds of sites where we're seeing a lot of PFAS are industrial discharges, where industries are either manufacturing PFAS or manufacturing goods that use significant volumes of PFAS. in their processes. The other kind of site is the AFFF, or the firefighting foam sites. And AFFF stands for aqueous film forming foam. And that's commonly used for jet fuel or fuel fires. And so it's found at training sites where firefighting training sites are done, at firefighting sites and military sites and airports. So the first kind of situation is the industrial. I was mentioning this is in Parkersburg, West Virginia, a manufacturing facility of DuPont that got in the news. Coming up in November will be a movie that sort of gets into the details around this particular story at DuPont's West Parkersburg plant. It's called Dark Waters, starring Mark Ruffalo. It's going to raise the hype on, or the concern, I think, about PFAS a little bit more. And then on the right here is a 3M facility in Minnesota. Then the firefighting type situations, again, 99% of the major PFAS sites that are in the news or are being tracked by Environmental Working Group and others have to do with industry and firefighting. And this is these kind of military and firefighting sites. Here's on the right here is an airplane. You can kind of see the wings here. It's not snow. It's not snowing. This is PFAS foam being blown onto the plane. It's a jet fuel carrying tanker plane. So a lot of potential for horrendous fire there. And so this video shows about 45 minutes of spraying the foam onto this site in New Hampshire, which resulted eventually in contamination of wells at the Pease International Trade Port. So these are significant events. These are of concern. These are things that need to be addressed. And these are the kinds of contamination levels we see. This is from the Environmental Working Group map, keeping track of different levels and different sites around the country. And these are the kinds of numbers you're seeing, you know, tens of thousands of parts per trillion in groundwater wells and drinking water. This is at firefighting and training sites. Again, tens of thousands, up to hundreds of thousands of PFAS, parts per trillion of PFAS. Obviously of clear concern. These are the sites that have been getting in the news that are getting a lot of great concern and are being addressed more and more by military and the state agencies. So there's another sort of order of magnitude lower bunch of PFAS out there. And this is where you all operate. This is where our wastewater facilities operate for the most part. If you happen to have a very large industry that's discharging that kind of level of stuff into your wastewater system, then you're going to have significantly different numbers. We'll talk a little about that. But generally, the vast majority of wastewater facilities, even landfills, septic systems, et cetera, are part of this ambient background. It's kind of demonstrated by this slide by a professor in Australia who kind of framed the issue, I think, best a couple of years ago. And biosolids and wastewater are really part of this typical background cycling PFAS out there. None of our facilities are adding PFAS to the process. We're all receiving it and conveying it. It's not breaking down in our treatment plants. These are persistent chemicals that don't break down. So we're just having to manage them at the end of the pipe, which we're all used to, right? That's kind of what you all do, what we all do. But this particular slide really clearly demonstrates that these major defense military sites, airports, and industrial sites are the ones that are most concerned. These are the high priority sites that society should deal with, where a lot of risk can be reduced by taking action. When we get into this background, ambient background stuff, which wastewater facilities and even landfills are part of, it gets a little tougher, okay? And we'll talk about that. PFAS are in wastewater and biosolids. Of course they are, because our waste streams mirror the chemistry of our lives. So these are not, PFAS are not coming into wastewater facilities only from industry. In fact, a large portion of what you see in a typical wastewater coming to a wastewater treatment facility is from everybody's homes and businesses and from us. It's just the nature of things. There are so many different commercial products, so many things in our homes that have traces of these chemicals. And again, we're talking parts per trillion, so we don't have to have a whole lot in our home to add some to the wastewater stream. The issue when it comes to biosolids or water reuse is that these chemicals can leach to groundwater. When you put it in the soil, it doesn't break down like most chemicals of emerging concern do, and it doesn't sorb like some of the chemicals do. For instance, for example, triclosan and triclocarban, which were antimicrobials, they tended to stick in the soil. So even though they've been now phased out, which is a good thing, when they went into the soil, they don't move. They're not really biologically available. But with PFAS, the shorter chain PFAS will move some, especially, and they all do leach some. So that's the first worry. The other worry is that if we're managing biosolids or wastewater through incineration, we're going to have, we don't yet know well where the PFAS end up. That's still being researched. But PFAS destruction requires temperatures above 1,000 Celsius. So most sewage sludge incinerators are not operating at such high temperatures. There are a few, I believe, I've been told, but most don't. And so the question is, where does it end up? There has been some measurement in New Hampshire of the ash at Manchester, for example, and I've seen a couple of other tests. Doesn't appear to be in the ash, the residual. So it's going up with the air, probably. The question is it captured by the air control systems? So more work needs to be done on that. Again, the reason people worry about that, and again, one of the things we have to do is really be very careful about the thinking. We're talking about air emissions perhaps coming from these facilities that are really, really orders of magnitude lower than, for example, a manufacturing facility that's blowing PFAS out the roof from their operations. Those are probably the levels of going into the air from those kinds of operations. Those industrial releases are significantly higher, much, much higher than might be coming out of an incinerator, a sewage sludge incinerator stack. So we have to look at this, and we have to apply careful evaluation and research. And so here's the bugger, is that we are beginning to regulate PFAS, and I'm not making a comment on whether it's right or wrong to do so, but we are in reality regulating PFAS in parts per trillion, single parts per trillion to teens of parts per trillion in drinking water. And as you know, waters are related, so your wastewater and your drinking water are related, and the regulations will, tie together. So these are numbers in New Hampshire. New Hampshire became the first state to adopt a formal set of MCLs, maximum contaminant levels, for drinking water in the country. And these are quite low. There are other states looking at similar levels. Connecticut's looking at, is sort of using a guideline of 70 parts per trillion at this point for 5 PFAS chemicals together. So regulating at background, so there's a study from Cape Cod a few years ago looking at septic systems, and the PFAS chemicals they looked at are over here on the left side. And this is a logarithmic scale. The round circles here are the PFAS that were detected. These are in drinking water wells in a neighborhood where the only known source of any PFAS and other chemicals is from septic systems. So very much residential neighborhood with no significant inputs from any kind of industry or other source other than people's septic systems. And here, we're finding PFAS chemicals in the single parts per trillion, some of them getting up close to the teens, and New Hampshire is regulating in the teens. So suddenly home septic systems are the source of the contamination at levels that are getting close to regulatory levels. So that's the nub of the issue right there. That's it. These are so close. So let me go through some data. The data in the next few slides, so we're talking waters, so we're talking drinking water and surface water and such, and the convention is to talk about those in parts per trillion. Again, kind of compared to the fact the 70 parts per trillion, which is EPA's health advisory level for PFOA and PFOS combined. Connecticut makes it a sum of 5, but 70 is sort of the key number just to look at for comparison. And I'll show you some data on some various different materials. So here's groundwater. So in New Hampshire, there's one facility that had, back in the 80s and 90s, basically had a sludge monofill, so a surface disposal unit. It was unlined. They put the sludge there for a bunch of years. You got to think that back then, PFOA and PFOS, which are the most prominent PFAS chemicals, were in much greater use than they are now. They've been phased out since the early 2000s. There's been a voluntary phase out of those chemicals. So these are PFOA and PFOS levels in groundwater near that sludge monofill. And the sludge monofill is up here at the top, and you have some pretty high numbers. Again, compare this to the 70 parts per trillion standard. And so that's worrisome to regulators, obviously. Drinking water wells were found to be 0. Not necessarily then a big public health issue right away, but it raises regulatory questions. New Hampshire DS has gone out and looked at septic management facilities. So a lot of septic from home septic systems is brought to wastewater facilities. But in some instances in New Hampshire, there are separate septic management facilities, such as lagoons. I believe Connecticut certainly had some of those in the past as well. Some of them are unlined. All of them are generally lined these days. But of the 13 lagoons looked at in New Hampshire, looking at the groundwater nearby, 62% of the facilities have exceedances in their groundwater of the new New Hampshire drinking water standards, which happen to also be groundwater standards in New Hampshire. So that's a pretty high percentage of facilities that have been managing septic for years, are vital to the management of wastewater, and they are impacting groundwater at levels that are above the current standards. So that raises a question. So what happens when the agency finds that kind of impact from a company that's managing septic? They're beginning to, in New Hampshire, to require such companies to do investigations and then to actually mitigate perhaps any impacts, especially if there are impacts on neighbors' wells. So suddenly that company, which often, as you know, septic management companies may not be the biggest, not multinational corporations with a lot of money. So they are then stuck with some unexpected costs to address that and some liability, perhaps in the sense of a circular liability, a superfund liability as a responsible party for having managed the septic and had some impacts on groundwater. So society, we need to figure out, is that a fair way to put the burden on either septic facilities or potentially in the future wastewater facilities that are also managing PFAS-laden waters. So here's an example of some surface water numbers. So this is a landfill, the Hoosick River, with some monitoring wells at 21,000 parts per trillion under the landfill, unlined landfill. So again, some leaching just from the wastes that go in there. Old carpets, old clothing, other things that happen to contain these PFAS chemicals. And then the surface water gets a little bit of leached PFAS in it. Again, up to surface water here in a pond up to 1,200. The river itself, 9 to 10 parts per trillion. Again, close to that drinking water level that New Hampshire has instituted. So let's look at wastewater data then for comparison. So sort of keep those numbers in mind. Here's a New Hampshire set of data that's pretty large. One thing I should say about data is all of these data are from different labs doing different methods because there is no single approved method for testing and analysis of PFAS chemicals in anything but drinking water. The method 537.1 drinking water method for PFAS of US EPA is the only consistent method being used. And data shows that for drinking water, you can compare data from different labs. For anything else, i.e. wastewater, groundwater, any dirty water, and solids and soils, you're going to get different results from different labs, and we're seeing that still. So, and that can be considerably different. So it's hard to compare data sets. So all of the data I present here is for sort of understanding purposes. It would not be reliable for, say, regulatory purposes. But anyway, looking at the wastewater, we're seeing again that every single wastewater that's been tested has PFAS in it, and many of them are above the 70 part per trillion. This is in effluent discharged. And if you look at the New Hampshire numbers, which are down in here, pretty much all of these wastewaters are exceeding the drinking water standards. Now, of course, nobody's drinking pure effluent, and usually there's a dilution factor allowed in regulatory structures for people in discharging. But, you know, that has to be decided what that dilution factor will be. And that is not yet done. Here's some additional sort of comparison of smaller city up here, influent and effluent for different PFAS chemicals, a mid-sized city. This is New Hampshire DES data also, and then here's a little bit more industrial community here. Again, the PFAS are showing up, not all of them in every single one, but they're all of them have at least some PFAS of some sort. And the interesting thing that happens is that you look at the influent, for example, for this PFHXA chemical, that's a 6-chain version. You have it at 49 in the influent and 195 in the effluent. There's this complicating factor that there are longer chain and multi-branched PFAS isomers that will break down and leave behind these more stable perfluorinated chain compounds like the ones listed here. So these are kind of terminal products. These are the ones that are very stable and don't break down further. So you have bigger compounds that are coming into the wastewater facility, and in the aerobic process, they get broken down and leave behind more of these more stable chains. So it's difficult to do a mass balance in a wastewater facility because of this kind of complication. Landfill leachate. So a lot of landfill leachate goes to wastewater facilities, right? So there have been several studies about this, and several data sets are available. And yes, the numbers are pretty high. So Michigan study showed PFOA in the 16 to 3,200 range parts per trillion. Again, compare that to the 70 part per trillion drinking water number. And some of them are pretty high. But the fact is that the sort of the take-home point of all the studies that have been done so far have basically shown that that because landfill leachate is not usually a significant portion of the waste stream, you know, it's tens of thousands, hundreds of thousands of gallons, but it's diluted dramatically. That even if you took away the landfill leachate from a wastewater facility, you're probably not going to see any real change in the PFAS concentrations in the wastewater. So there are only a few facilities here and there who take in so much landfill leachate, and it's such a large proportion of their waste stream that they should perhaps be concerned. But generally, all the states that have looked at this closely are feeling like, no, we don't have to shut off landfill leachate at wastewater facilities. So biosolids and residuals, wastewater solids also, of course, have these in them. And again, there's no regulatory standards or anything on this. In this case, when we're talking solids, we're tending to talk in the parts per billion, so the data that follow are in parts per billion, which is 1 second in 31.7 years. So a little bit of context. So this, I apologize about the size of the slide. We have some data back from the from 2001 sewage sludge nationwide. It had an average of PFOA of 34 parts per billion and PFOS at 403 parts per billion. So those are kind of useful numbers for back then when there were higher levels of these because they had not been phased out yet. Dust in daycare centers, 142 parts per billion, 201 parts per billion, just for comparison. So again, these are around in our environment. Of course, nobody's eating a lot of dust, but some children are exposed in that way. Garden soils are in the 0.34 to up to, from half to 1 or 2 parts per billion That's a control set or background. So background in where it's been measured, including in Vermont, a big study there, shows about 1/2 to 2 parts per billion in the soil. That's background, so we have to remember that. Septage has PFAS in it. Here, some septage data, PFOA here, from 6 or 7 different samples. Here's PFOS, measured in Maine. These tend to be about twice as high as most sewage sludges, biosolids, which is interesting. We think it's probably because the septic systems, the material's been sitting there a little bit longer. Some of it may not have been pumped for 10 years, and the phase out of PFOA and PFOS has gone on during that time period. So you're getting some older, more concentrated stuff coming out in septage, perhaps. This is what biosolids tend to look like. So this is the 0 to 1,000 parts per billion scale at the bottom, and these are each different compost or biosolids compost or sludges or biosolids products in New Hampshire. And again, some of them have really high levels of PFHXA, for example, this blue stuff. And that's PFHXA is a more common recent replacement chemical, six-chain version, less toxic, less concerning, and it's being used in place of the PFOA and PFOS that have been phased out. So there's some additional data here from Maine, which has tested a lot of biosolids, and the mean, the average is this gives a pretty good sense of what the averages are, 8.5 and 25 for PFOA and PFOS respectively. So that gives you a sense. The usefulness of these data is to begin to give us all a sense of what's normal, what are we expecting to find, and then what does that mean. We don't have risk assessments done. We don't understand what the impacts could be. But of course, not many people are exposed to biosolids, so we don't have to get freaked out anytime soon. This also, this slide shows on the left that these are composts made from food waste, the tall ones here, and this is yard and leaf waste compost. So even yard and leaf waste compost includes some PFAS, and food compost definitely includes some PFAS. And that's from food contact containers. It may be some compostable foodware that was in that compost. Biosolids and wastewaters are not the only source of these in organic residuals. There are a few instances, though, as I mentioned, where we have had large industrial discharges to wastewater facilities that have impacted the wastewater and the biosolids. And Decatur, Alabama is one in particular that is well known, where a 3M manufacturing facility was discharging to the sewer for a long time. The biosolids were impacted. That impacted some farms where the biosolids were used. Yes, obviously concerning. We need to learn from those kinds of experiences. Similar thing found in Lapeer, Michigan. More recently, there is this thing, anybody heard of the Maine farm situation in cows in Maine? Oh, I don't want to bring it up to you then. Not many have heard of it, but for those who have heard of it, it got in the news and it really rocked our industry. And I'll get into a little of the details later, but it was an industrial material that was placed on the farm, on one part of the farm. Other parts of the farm only received municipal biosolids, and those have pretty typical the kind of background levels we expect and find elsewhere. But where that industrial material was placed created a large, high level of up to 878 parts per billion in the soil, which is really quite high from what we've seen from other data. Here's the information from Vermont. Vermont did a statewide study to get background levels in soil. Every single sample had some PFAS in it, even in pretty remote sites. 60-some samples all across the state, and these breakdowns sort of show that how much total PFAS was in each place. So 8 locations were above 5 parts per billion. This data here is in nanograms per kilogram, which is parts per trillion. So 5 parts per billion, a bunch of them, and then a lot of them were down in the 1 part per billion range or lower. But it's there. So we're working in biosolids, and biosolids being applied to soil. We're kind of interested, and states are interested where biosolids recycling happens, in what the leaching potential is, and we've been working on assessing that. And encouraging further research, because there are data gaps that don't allow for a good risk assessment still. It's important to note that 60% of the sewage sludge produced in the U.S., including from Chicago, Boston, Detroit now, Denver, San Francisco, Seattle, Los Angeles, they're all recycled to soil as organic amendments. And so understanding what the leaching potential is related to PFAS is important. We've had a study done by Stone Environmental, which began to get at this issue and has some results that suggest we can go to tens of parts per billion probably as screening values, but we have a lot more work to do on that. So what are the policy and regulatory things? So as I said, two big things have happened here in New England, I think have impacted the solids management market. Obviously here in Connecticut, where most of the solids are incinerated, almost all, it may not have impacted things as much, although I think it's put a little pressure on the market because there have been solids in Maine and in New Hampshire that can't be land applied anymore, and they were last year. So they have needed to find a place for those to go, and the markets are reacting with higher costs and such. There was this reaction to this particular farm in Maine I had mentioned, where it was industrial material that caused the issue, but that was not reported in the news, unfortunately. We have a fact sheet on it on our website. I'm glad to share that with you. When Maine DEP did do a lot of testing of the biosolids, only one of many did not exceed their very low screening values of 2.5 and 5.2 parts per billion. As you saw in the graphs about the levels in biosolids, those numbers just aren't possible for most biosolids. Sewage sludges, just naturally, even from the most domestic small town systems, will exceed the 2.5 parts per billion, the 5.2 part per billion levels. One or the other will be exceeded by pretty much every biosolids. And we knew that going into this. The state of Maine sort of rushed into it without realizing that would be the case. A lot of the soils where they required testing of soils where biosolids were applied multiple times, and a lot of those did not meet. So it's an ongoing challenge trying to figure that out. But based on the main data we've collected so far, we see that a typical multi-year biosolids application site, some that have been getting annual applications of biosolids for decades, up to 30 years, they don't seem to have impacted groundwater above the 70 parts per trillion screening level that Maine is using. And testing of milk and silage feed and other things which were done by the state did not find any detections in those products. So the normal biosolids application programs are not impacting the food and quality of the situation, even in Maine. New Hampshire also has now adopted the strictest in the nation drinking water and groundwater standards. As I mentioned before, here are the numbers. The cost that they have estimated, and it's just for 6 wastewater facilities to adapt and for all the drinking water facilities to test and adapt, is $267 million. New Hampshire is only 1.5 million people, so the cost is huge. And this would be borne by municipalities and utilities. There is no money provided from the state to deal with this. So this is, we believe all wastewater facilities will eventually be impacted. Septic management will be impacted. There will be private companies that will be impacted. So the cost, we believe, will be 3 to 4 times higher if the full ramifications and the full enforcement of these regulations continue forward. There was a pushback on this. The process by which those regulations were adopted did not include a cost-benefit analysis, a thorough cost-benefit analysis. So there's been a focused pushback to require the state to go back and do that full analysis. A lot of state actions are pending then still on this. The important point, though, is that the vast majority of states are not rushing ahead to get to strict regulations. They're trying to figure it out. They're trying to watch and see what EPA does, watch what other states experience. Here in New England, we're rushing ahead at a faster pace than most of the rest of the country. So there's been impacts in northern New England, especially on biosolids management, wastewater solids management. Prices have almost doubled. A lot of communities have decided to truck to Canada in order to reduce their potential risk. 60% of the main farm fields that had received Class B biosolids from a number of facilities there can no longer receive those. Costs have increased to those farmers because they're not getting the benefits of the biosolids. And all of this is integrated, and so the impacts are, will reach into the general market of solids management. And so we also think that, wastewater is going to be impacted. It's something we have to watch, because what your effluent discharge limits might be depend on what the drinking water standards are, what the surface water standards are, et cetera, et cetera. They're all linked together. In Michigan, for a couple of years, they've been using 11 or 12 parts per trillion, 11 or 12 parts per trillion as a surface water screening value. They've been applying that to wastewater effluents. And they're asking utilities to try to reduce their PFAS below that number. Some can do that, but a lot will have difficulty doing that. So what's happening in Connecticut? Well, you know about the Farmington River situation and that unfortunate spill of firefighting foam. And again, that's one of the two major sources. Industrial and firefighting discharges to the environment create large issues and need to be addressed and are of concern. The Connecticut Task Force, as you know, just completed their initial report October 1st, and they've, I think, taken comments. I think that comment period is closed unless somebody changed it. It was the 15th of October. And the report summarizes work that has been happening to date, and it has recommendations from 3 different committees. One committee is focusing on protecting Connecticut citizens and reducing exposure. One is looking at minimizing future releases, and the third is looking at remediation, identifying and assessing and cleaning up historic releases. So those are ongoing. I think the report and the approach of the task force has been reasoned and thoughtful. And it hasn't, for instance, in Maine, the reaction has been really focused on biosolids only for whatever reason. I think this is a more holistic approach. But these are the kinds of things that are recommended. And as you'll see, evaluate the levels of PFAS that reach wastewater treatment plants, biosolids, and compost. So we're on the hook. Testing is coming to a theater near you fairly soon. There's also potential legislation being considered. And so that'll come up presumably in this short session, perhaps coming up. The questions, not all of these are kind of prudent steps. It's obviously a really good source control is a really good way to go. So taking back the AFFF, that firefighting foam, getting it, collecting it. Massachusetts has done that, and it's been successful. So there can be other measures. Require all water bottlers sell bottled water to test their water, because drinking water facilities are also being, treatment facilities are being required to test. So there's ways that we can move forward. Here's the timeline of that. So pay attention and watch. Interim guidance for wastewater and biosolids management. Not a whole lot you need to do right away, but be aware that sometime you're going to be asked to test perhaps. You've got to decide how you're going to do that. We really suggest you plan carefully how you're going to manage the data, what the data are going to mean. You're going to find PFAS. How will you communicate that? There is no zero PFAS in wastewater. I'll repeat that. There is no zero PFAS in wastewater. So you'll find it. You'll have to communicate that to your public and your regulators, et cetera. And make sure you pay attention to how you sample and all that, because there's easy cross-contamination can happen in the sampling. An easy thing our industry can do to start is to begin to, and the concept is easy, but actually doing it is still being worked out. But begin to look upstream. If you have a 3M upstream, you might as well talk to them and see, are you discharging something to our sewer? Can we begin to have some discussions, with industries that may be using or manufacturing these materials? You're not going to get them out of every household or septic discharge, or out of every mom and pop shop that happens to use a little bit in some paint or oil or something. And you probably don't need to worry about those. But if there's some big hitters upstream, obviously that's an easier way to do some source control. And then track what's going on and get involved, because it's coming as an issue. There's a lot of public pressure on states to do that. I think we really need to be careful with how we think about this, compare risks. Again, orders of magnitude higher impacts from industry and firefighting activities compared to the ambient background stuff most of us are dealing with. So let's make sure we stress that to everybody. We don't need to rush out and try to capture every little bit in our wastewater when we've got these huge sites that are sitting out there and need a lot of attention. Think carefully about chasing those ambient background. And right now, PFOA and PFOS have been phased out. So they're kind of legacy contaminants. You know, how do we address those compared to others? We need to focus on advancing understanding. Collecting more data is useful. We already have a lot of data, though, so you know, you may be interested to go out and find out what your wastewater is, and the state is going to at some point come and ask for testing. But in reality, we know it's there. We need to spend more time and energy on understanding what it means that it's there. Is it a concern? So rather than spending a whole lot of time and energy and money getting more data, maybe we should spend the money in better ways. And know the full repercussions of any policy or regulatory action. As I said, in New Hampshire, we're regulating in the teens of parts per trillion drinking water and groundwater. And there are a lot of sites, the state estimates at least 10% of homeowner wells, private wells in the state, are probably going to be exceeding those numbers. That's huge. What does that mean? Is that doable, that we can even begin to pretend to regulate and enforce at that level? So where are we going to be? Like many CECs, like dioxins and PCBs, we're going to learn to live with these because we don't have enough money to get it out of ambient background levels, right? These are not going to go away. No matter how much we try to do, we don't have the money to address it. So we're going to get used to the idea that, okay, these things are there. We're going to focus on drinking water protection and other direct contact sources, food, for example. We're going to phase these out. We're going to have thermal destruction systems to take care of the more contaminated waste. And then the solids will still have to be managed, and we'll still be managing wastewater. But how many programs will have been disrupted? How much more will it be costing? And will other priorities have lost out? In other words, you have plenty of priorities that are important to your utilities that you're working on to protect public health and the environment. And this has the potential, and has in Maine at this point, to disrupt and put all those other projects on hold because of the cost of PFAS management. So as a society, we need to learn from what we've seen happen in Maine and New Hampshire, and we need to proceed slowly and with eyes wide open as to what the impacts will be of the regulations as they develop. So get involved. We're getting help from the national level, and that's a good thing. Right now, there's a bill before Congress, or amendments to the National Defense Authorization Act, that have been introduced. A couple of the amendments would require a listing of PFAS chemicals under CERCLA, the Superfund law. The only issue with that, I mean, it's got a lot of good things to it, but the only issue is that at this point, that could mean that a wastewater facility, a utility, a municipality could be a responsible party under CERCLA and have to pay the cost of cleanup of a river, or of a site where biosolids were used, or your ash landfill. That has not been sorted out. You know, there's in CERCLA at the federal level, there is some exemption for municipalities for certain things, but that has not been included. That kind of exemption has not been included in the current legislation. So that's a concern. If you get newsletters from WEF or NACWA, they should, you've gotten some alerts to this, and we encourage you to write, to contact your congresspeople. It's being decided right now. So here's the hopeful side of this, right? US EPA voluntarily proactively worked with companies, and they voluntarily phased out PFOA and PFOS. So those are legacy contaminants really in North America now. They come in on goods from overseas, yes, but they are fading. And the beauty of it is the data. When you look at the most important data, which is the levels in human blood, dating back to the 2000s and before even, CDC was testing human blood for PFAS chemicals, and we all had it in us. 99.9% or 98% of the population has PFAS in their blood. Sorry, that's just the reality of it. And it was at much higher levels back then, in the late 90s, than it is today. And that's because of that phase out of PFOA and PFOS. And so that one action of phasing out this chemical has been the most significant and important action that's been taken so far. So this is an indication, a good guidance of what we need to do. So in summary, relatively minor amounts of PFAS are conveyed to the environment by typical municipal wastewater, but it's there. PFOA and PFAS, the most concerning, have been phased out, so that's a lesson to remember. Recycling municipal biosolids to soils has not caused known impacts to food products and to groundwater above the 70 part per trillion standards. Receivers of PFAS, like municipalities and utilities, cannot carry the major burden of addressing PFAS at the end of the pipe. The costs could be significant for our utilities, and so society, states, and federal government have to help carry the burden financially on that. Water resource recovery facilities can proactively follow and update best practices and cost effectively reduce potential risks, some by looking upstream and doing source control and following best management practices. And regulatory agencies should be aware of unintended impacts of regulations along this. We have a bunch of resources on this. I've been working on it, as I said, for about a couple of years, more than 2 years. And so we have a public facing page that has our basic message, and we also have restricted access information you can contact us about. So thank you. Apologize for going a little over, but I hope it's useful and glad to answer any questions you might have.
Question here.
Yes.
A couple questions. The old land sites that are shut down, because they're exceeding the 12 number in hours, or is it fear of the landowner from the public perception?
So the first question was whether the sites where, farm sites where biosolids are no longer being used. This is in Maine, I think in particular. That's the state where it's played out. Is that because of landowner concern, or is it because of regulatory exceedance? So what Maine did is they had sort of done this risk assessment back in 2017, early 2018, and put some PFAS numbers into a table that really is not related to biosolids management. But when this concern came up suddenly in March of this year, they went and grabbed that number. They said, oh, here's a number. We'll apply this to the biosolids, and now we'll say no biosolids are going to be land applied in Maine until you test. And if you don't meet these numbers, then you'll have to do further risk analysis or evaluation. So they use that number for the biosolids, and they also use those numbers for soil levels. So the sites where biosolids can't be applied anymore on farms is because the soils there exceed the 2.5 and 5.2 parts per billion for PFOA and or PFOS at those sites. And that's when we look at long-term land application sites that have received biosolids for 10, 20, 30 years, they all exceed that kind of level, 2.5 to 5.2. That level, we believe, is completely inappropriate and not applicable to a biosolids land application scenario. And the numbers, the modeling we're getting out of these expert modelers looks like it's at least an order of magnitude higher, probably more like 20 to 30, 20 times or 30 times higher would be a more reasonable screening number. So, second question.
Until that all gets worked out and resolved, if you can get the higher numbers, a little more logical thinking here. It sounded like a lot of that waste, because it can't come down south because all the incinerators are at capacity. It's going up to Quebec. Are the Canadians looking at PFAS? Anything happening up there?
So one of the things you'll notice in the PFAS regulatory structures, and we have a matrix, a spreadsheet essentially on our table on our website that shows you the limits. It was just updated yesterday. In different states for drinking water numbers, surface water, groundwater, and soils. And there aren't many numbers in the soils and surface water area. But drinking water standards go from, it's like 100 parts per trillion is the kind of number being used in Europe. in the most conservative countries. Canada has 200 and 600 for PFOA and PFOS for drinking water standards. That was finalized December 2018. So very recently, their risk modelers, their toxicologists use different assumptions and whatever. Here in New England especially, but in the US generally, we're using very conservative assumptions layered on top of each other. So we're down in these tens of parts per trillion for drinking water standards. EPA 70 parts per trillion. Many toxicologists argue that's too conservative, the 70 part per trillion. But here in New England, we're all talking 20 or lower. And so it's all over the place. So at this point, Canada is not so worried. And that farm situation in Maine, for example, which blew up the whole issue in Maine, if that farm had been in Canada, there was no issue with the drinking water, with the milk, with anything under Canada's regulations. Anything else? All right.